All right, today we're diving headfirst into something called the new algorithmic battlefield. And look, this is a huge shift in how modern conflict works. We're talking about a world where life and death decisions are starting to move away from human hands and into the cold, lightning-fast logic of pure code. Just listen to this. We are now entering an era where algorithms make life and death decisions in milliseconds. Think about that for a second. This isn't some far-off sci-fi movie concept. No, this is the reality that's unfolding on battlefields right now. The very nature of combat is being rewritten. And you know what? It's not being rewritten by soldiers, but by software. So, what exactly is this algorithmic battlefield we're talking about? Well, put simply, it's the shift away from wars fought at human speed, the speed of human thought, to wars fought at machine speed. And that's a change that is honestly absolutely fundamental. And the contrast between the old way and this new way, it's really stark. Think about it. Traditional warfare, that was all human-paced. The decisions were made by people, the impact was usually localized, and there was always direct human control. But this new paradigm, it's a whole different beast. We're talking machine-speed decisions, operations that are networked across the entire globe, and this is the big one, a steady, undeniable march towards more and more machine autonomy. Okay, so to really get a handle on this, let's look at a real-world example. We'll start with how this AI is being used for defense. Think of it like a digital shield designed to protect actual human lives. I'm sure a lot of you have heard of Israel's Iron Dome, right? It's probably one of the most famous examples of defensive AI in action today. It's a system built for a very specific job, to stop fast-moving, short-range threats like rockets. So how does it actually work? Well, the process sounds pretty simple on the surface. First, radar picks up an incoming rocket. Then comes the magic, the really crucial part. An algorithm calculates the rocket's trajectory to figure out where it's going to land. And it does this in seconds. If the calculation shows it's heading for a populated area, boom, an interceptor is launched to take it out. The key thing to remember here is that a human brain just can't do those calculations fast enough to make a difference. It's physically impossible. But, and this is a really crucial point, the very same principles that can create a shield can also be used to forge a sword. This technology is, dual use, and we are absolutely seeing it being used for offensive systems too. So what does that look like on offense? Well, you've got AI-powered systems that can identify and track targets all on their own. You have drones all over the world carrying out complex missions with less and less human input. And maybe the most game-changing thing of all is the rise of swarming. We're talking about hundreds, maybe thousands, of drones acting like a single, coordinated intelligence, a sort of thinking hive that can just completely overwhelm any traditional defense. So you see, whether we're talking about defense or offense, what's the one thing they have in common? It's speed, an incredible, almost unimaginable speed. And what that speed does is it just crushes the amount of time a human has to make a decision. Milliseconds. Let that sink in. A single blink of your eye takes about 300 milliseconds. These systems, they're designed to detect, decide, and act in a tiny fraction of that time. It's a speed that is it's completely beyond human capacity, period. And that speed, it forces us, it pushes us towards a really critical question. In a fight that's moving that fast, is there even time to ask a human for approval? What happens when the human is taken out of the loop? Not because we want to, but because we have to. And that question, well, it leads us to the logical and maybe a little unsettling conclusion of where all this is going. It's forcing us to look square in the face at the future of autonomous war. And what is autonomous warfare? Let's be really clear. It means we're talking about systems that can make the final lethal decision entirely on their own. They can search for, identify, target, and engage a human being, all without a person ever having to give that final go command. And that leaves us with a huge, incredibly complex question to wrestle with. As we hand over this life and death authority to lines of computer code, who is actually accountable in the end? When an algorithm makes that final call, who's responsible? Is it the programmer who wrote the code? Is it the commander who deployed the system? Or is it the machine itself? That right there is the central, unanswered challenge of this new algorithmic battlefield.